Have you ever seen an algebraic fraction like this, x plus 2 all over x minus 3, and thought, what am I supposed to do with this? Don't worry, in this lesson, I'm going to show you what rational expressions are, how to simplify them, and how to identify the restrictions, and finally, how to solve problems involving rational expression step by step. Now, at the end of this video, rational expression will be much easier for you. Now, welcome to Daniel Maths Academy. And if you are a grade 8 or 9 student studying algebra, this lesson then is for you. So, in today's class, we will be looking at the topic rational expression. Let's look at the outcome of today's lesson. Now, at the end of this lesson, you will be able to discover what a rational expression is. Number two, you will learn about restrictions on variables. Number three, you will learn how to simplify rational expression. Four, we'll look at multiplying, multiplication, and division of rational expression. And finally, number five, we'll look at real-life applications and solve questions. Before we dive into the main lesson, let's see what are the benefits of rational expression in other areas of our study. So, in this learning rational expression, we prepare us for solving more difficult algebraic equations, working with functions and graphs, solving quadratic equations and inequality, working with rational equations, and it will also help in studying advanced mathematics, physics, engineering, economics, and other STEM subjects. And with that, we've come to the beginning of today's lesson. When we talk about rational expression, what comes to your mind? A rational expression is, first of all, an algebraic expression. Take note of the key word, the expression. Rational expression is, first of all, an algebraic. Take note, is first of all an algebraic what? Expression. Right? It is an algebraic what? Expression that can be written as a ratio of two polynomials. So when we talk about the ratio of two polynomials, you can see here this is a ratio of two polynomials. So this is the first polynomial that found in the numerator, x plus 2, and the second polynomial is x minus 3, and this is the ratio. That means they're dividing each other. So an example, and then also take note that the third characteristics of the rational expression is that the denominator is not zero. So the moment your denominator is zero, then it's no longer a rational expression. Now, likewise, is x squared plus 9 all over x plus 3 a rational expression. And finally, we have 5 over x is rational expression. So now, how can we use rational expression in our daily life activity? So why is rational expression useful? Someone might ask. Now this is the reason. So let's connect this to real life. And in this situation, imagine your family is planning a road trip. All right. And in this road trip, the total transportation cost is 120,000 naira. If X members of your family are going on the trip, now, the amount each person pays can be represented by this expression, which is 120,000 divided by x. So you see, this is one of the applications of rational expression. You can use it to analyze question. Now, let's consider the situation whereby if 5 members go for that trip, so we're going to use the expression 120,000 divided by 5, and that is going to give us 24,000. Each member pays 24,000 to attend the trip. But what happens if we have 12 members who want to go for the trip? Therefore, we're going to have the expression is going to become 120,000 divided by 12. That's going to give us 10,000. Now, this means each person is going to pay 10,000 naira for that trip. Now, From this, you can see that rational expression can help us describe relationships involving cost, quantities, rate, time, and changing values. Now, this is one of the things that we've seen from rational expressions. Okay, now it's time for us to look at the next concept that deals with what? Important restrictions. So, before that, now, what are rational expressions, and we'll look at what rational expressions are not. Now, so look at this now. We can look at the rational expressions. Expressions such as square root of x plus 2 cannot be said to be a rational expression because we said rational expression is a ratio of two algebraic expressions. Now, this is not an algebraic expression, rather, it's a sodic, it's a radical. So, these expressions, sodic expressions, are not considered as rational expression. Now let's look at the next part of this. All right. Now, so what are the things next? We want to look at important restrictions. And important restrictions helps us to know the particular value that we cannot use, because if we use that particular value, this whole system is going to become undefined. So what makes x not to become zero? I want to look at. All right. So if in this lesson we're going to see this, and then so let's look at this example here. Example here says simplify 3 over x minus 4. Let's see if this question is an algebraic expression. But look at the caveat by the right side. Before applying a rational expression, you must identify values that makes the denominator to be 0. So let's look at this. Now from here, so we have to equate x minus 4. Let's use a different color. So we have to equate x minus 4 to be equal to 0. Now we'll solve from here. We will say that x, if you add, you do the additive inverse, so that means we're going to add 4 to both sides. So this is going to become x minus 4, and then plus, we're going to have plus 4, we're adding 4 to both sides, right, is equal to 0 plus, and then we have here, well, since we're having 4 to both sides, so let's see what we're going to have from x. Therefore x is going to be, so this is going to become 0, so s is finally going to become 0 plus 4, which is equal to, therefore x is equal to 4. Now, so if this expression must exist as a rational expression, x must not be equal to 4. X must not be equal to 4. This is basically what it means for this particular concept, right? Get that? Look for a number that must not give the result of a denominator to be 0. Let's look at the next one now. Now this is yours to practice. Pause the video, use the same concept, look out for a way that what number must you add that will not make this to be 0. Think of that number. All right, welcome back. So one of the ways we need to do is quickly, we need to substitute and equate x plus 2 to be equal to 0. If we do that, we're going to do the additive inverse. So at the end of the day, x is going to be equal to minus 2. So it means that x must not be equal to minus 2, because if that happens, then this is going to become, so this is going to become 7 all over a minus 2 plus 2, and this is going to give us 7 divided by 0, and this is undefined, because if you press this into your calculator, it gives you undefined, or what we call math error. All right, so this is one of the ways on how we can find the conditions, right? The restricted conditions. So now let's look at the next one. Now this is one that you're going to do. Okay, let's look at this together. Now, what happens if our denominator is a quadratic function? What do we do of quadratic expression? So what we're going to do there is simple. We're going to factorize first, and then before we find out. So how do we factorize this? Now, x squared minus 9 can be factorized into using difference of 2 square. That means we're going to have x squared minus, what is the number that can give us the square of 9? What number that what is that number that when you square gives us 9? That is 3. So this gives us 3 square. But hello, come on, there's a secret that we have here. There's a concept that we must recall. So if we recall this, that a square minus b square can be written as a minus b times a plus b. So this is difference of 2 square. If we apply that concept here, this is going to give us x minus 3 and x plus 3. So this is the simplification of this. Now let's go back to the question. So we will write our question back. This is going to give us x plus 2, which is our numerator down here, dividing by, now this is going to be divided by x. This is going to be divided by x minus 3 and x plus 3. So x minus 3 and x plus 3. All right. So then at this point, we need to cancel out common terms. All right. So what are the common terms that we can cancel out from there? All right. So if you look at that, you see, so we're really not cancelling, but from this we're going to find out what are the values. So therefore, so consider here that x minus 3, so you can now equate this, that you can see that x minus 3 and x plus 3, we're going to equate them both to 0. So x minus 3 is equal to 0 and x plus 3 must be equal to 0. So if this 2 is equal to 0, means that x is equal to 3 and x is equal to minus 3. So the two values that they must not be equal to is x must not be equal to 3 and x must not be equal to minus 3. So this is the solution to this question, finding the boundary condition for this question. Similar with this, I'm going to leave this for you to solve, and then once you're done with this, we'll move on to your practice activity. Now this is a question that you have to find the excluded values. 4 divided by x squared minus 16 and x plus 3 divided by x squared plus x minus 6. All right, so this is where we're going to stop on this introduction. Remember, a brief recap of what we've done. We started by looking at what is rational expression. After that, we went on to look at what are the different restriction conditions that can be applied to make a rational expression valid. Now, then we also looked at real life application of rational expression to see what it can be used for. In the next lesson, we'll be looking at how to simplify rational expression. So stay put and we'll see you in the next lesson. Don't forget to like and share this video on our YouTube at Daniel Maths Academy, and then like, share and subscribe. Till we see you again in the next video. Bye for now.